All right, today we're going to crack the code, the secret language that powers, well, everything in our digital world. Think about it. It's a language with just two symbols, but out of that we get everything, from a simple text to these insane, breathtaking video games. And you know what? It all kicks off with a really simple puzzle.
So here's the question for you. How can you count all the way to 31 using just the fingers on one hand? And yeah, each number has to have its own unique finger combo. Go ahead, take a second and think about it. I promise this isn't a trick question. There's a real answer.
You see, to solve this, we have to start thinking about our fingers in a totally new way. And believe it or not, this little hand puzzle holds the key to understanding how computers actually think.
Now, we're all used to counting where each finger is just 1. 1, 2, 3, 4, 5. But the secret here is to throw those rules out the window. What if each finger had its own unique value?
Okay, here are the new rules. Your thumb, that's worth 1. Your index finger is 2. The middle finger is 4, ring finger is 8, and your pinky is a whopping 16. See that pattern? Each finger is just double the value of the one before it. We're talking about the powers of 2 here, and this is absolutely fundamental to how this whole thing works.
So now we have the values, right? But how do we actually use them to count? This is where it gets really, really clever.
It's honestly as simple as this. A finger held up means it's on and it's contributing its value. A finger that's down is off. It's contributing 0. This simple on-off switch, you have no idea. This is maybe the most important concept in all of computing.
So, to make any number, all you do is add up the values of the fingers that are on. Simple as that. So let's say you want to make the number 5. What do you need? Well, you need a 4 and a 1, right? So you raise your middle finger and your thumb, and boom, you've got it. And what about getting all the way to 31? Well, you just raise all 5 fingers. That's 16 plus 8 plus 4 plus 2 plus 1. Pretty cool, huh?
Okay, so let's jump from this fun little hand trick to the language that basically runs our entire planet. Because this isn't just a puzzle, it's a perfect analogy for how computers do their thing. You know that on-off state of your fingers? That is exactly what's happening billions of times a second inside your computer's processor. The only difference is, instead of fingers, it's using these tiny little electronic switches that are either on or off. There is no in-between.
This really shows you we're talking about two completely different worlds, right? Our world, the human world, is decimal. We call it base 10 because we use 10 digits, 0 through 9. But computers, they live in a binary or base 2 world. They only have 2 digits to work with, 0 and 1. Off is 0, on is 1. That is literally the only language they speak.
So let's make it official. The name for this is binary. It's the primary language of computers. A 1 just represents an on state, an electrical pulse is there. A 0 represents an off state, no pulse. Every single thing a computer does, and I mean everything, boils down to a long sequence of these 1s and 0s.
So, as humans, if we really want to get what's going on under the hood of our devices, we need to be able to switch between our world, decimal, and the computer's world, binary. So, let's learn how to translate.
Hey, this looks familiar. It's just like our hand. The columns have the same values, 1, 2, 4, 8, 16, and you could keep going. To translate a binary number like 10101, you just look for where the 1s are. So we've got a 1 in the 16's place, a 1 in the 4's place, and a 1 in the 1's place. Then you just add them up. 16 plus 4 plus 1 gives us 21. That's it.
Okay, I bet you've got this. Let's do a quick test just to make sure it sticks. I'm going to throw a couple of rapid-fire questions at you. Ready?
First one, what is the binary number 101 in our system? Think about those place values. You've got a 1 in the 4's place and a 1 in the 1's place, so what's the answer?
It's 5. That's it. 4 plus 1. Nice one. You're actually reading binary right now.
Okay, let's try one more. This one's a little bit trickier. What is 10011 in our decimal system? So think about the places again. 16, 8, 4, 2, 1. Where are the 1s? And the answer is 19. You got a 16, a 2, and a 1. Add them all together, you get 19. See? It's not so hard. You're already translating between human and computer.
But now we're going to zoom all the way out because the implications of this super simple system are, well, they're truly mind-boggling. It's not just about counting numbers. It's about everything. You know, every single letter that you type, every character you see on the screen, is just a specific agreed-upon pattern of ones and zeros. The letter A isn't actually an A to a computer. It's just the code 01100001.
I mean, it's such a profound idea when you really stop to think about it. The music you're listening to, the photos you scroll through, even these incredible, complex 3D worlds in a video game, every single color, every sound, every movement, it all boils down to just an impossibly long and complicated sequence of simple ons and offs. Ones and zeros. That's it.
And that kind of leaves us with one last big thought. Our entire, incredibly complex digital world, our whole civilization, really, it's all built on the simplest possible foundation you can imagine. Yes or no, on or off, 1 or 0. So it really makes you wonder, right? What's the next huge, world-changing idea that's going to be built from a code that's just that simple?